Hello, everyone. All right, I think it is being not broadcasted now, so that is a good thing. So I don't know how many people are here. It looks like 3 people possibly only. So I'll probably just field some questions and we can make this relatively quick. So that'll be fine. That will be fine. Just posted. All right. Yazzy's here. That's good. All right. All right, I'm just trying to get the screens all arranged and everything, and then we can go into some questions here, and that will be fine. That will be great. Hey, Yazzie. What's up? All right. I mean, I can probably do a quick rundown of the 3 sections that are the new ones in the. Right. I mean, I can probably do maybe a 10-minute sort of just general review here. Okay, so we can just do that while we're waiting around here. All right, essentially we have, 11.1 through 11.3 were already covered in the quiz. Okay, so that covered basically things like 11... what was that? 11.1 was, it was tangent properties, basically. So radius and tangent form right angles, tangent segments are congruent, stuff like that. 11.2 was central angle and arc properties, right? So we had properties like the measure of the arc is the same as the central angle. We had that congruent chords, I think, cut congruent arcs. If we had a chord that was perpendicular to a radius, it bisected the chord, stuff like that. Again, things that we talked about before, but basically 11 and then 11.4 was arc lengths, 11.3 was arc lengths and area of sectors. So we did that as well. Okay, so 11.4 is when it starts to get new here, and I'm going to actually just jump into the homework, or I'm going to look at it. I'm going to have it on the other screen so I can make sure I'm covering everything here. And essentially, I believe it came down to having inscribed angles, right? So the main thing was that we had an angle made up of 2 chords, and the angle of 2 chords, right? This angle right here, the vertex is on the circle. We know that the measure of this arc right here, okay, so we could call that arc AB, right? The measure of arc AB is going to be 1/2 the measure of this angle here, so which we can just call angle C, right? So half this angle is going to be the arc. And again, you could do that with a bunch of things. And so we could apply that to a few other things here. For instance, we could apply it to the fact that if we had a diameter, right, then the diameter cuts this into 180 and 180. So if I have an arc that sort of goes to this diameter here, right? So if this arc right here, well, this is this is an inscribed angle to this 180-degree arc. So I know actually that it has to be a 90-degree angle, and therefore we have a right triangle, right? So that was definitely one of the properties. And of course, we have a right triangle. We know a lot about it. We can find, different things, right? We can find different things. So let me just make a note here. Hold on a second. 1 second. Never mind. I can't seem to do that. Okay, whatever. All right, so hi Alexis. All right, so that was a central angle, and then we also knew that if you add some, like the fact that if you add more than one central angle to the same arc, right? So we have it inscribed to this sort of arc here. Well, to that same arc, we have another angle. Well, we know that these two angles are the same, right? Because they're going to be half the same arc, essentially. And of course, there's other problems with that where we can sort of sort things out. But those were the main things. There was one other thing where it basically said if you had, and again, we went over why this was the case in class, but if we have an inscribed quadrilateral, any quadrilateral that's inscribed, right? What we know is that the angles opposite of one another are supplementary. So they add to 180, right? That was a property of inscribed quadrilaterals. So once we sort of knew, got that, then we're good. All right, so that was 11.4. 11.5 was basically a couple things. It dealt with angles, different angles inside or outside of circles. So the first thing was that if we have a tangent and a chord, right? This angle here would be half of this particular arc right here, right? So the arc that the chord cuts is going to be is going to be double the angle, right? So again, if this arc was 100 degrees, this angle would be 50 degrees, which would make this angle over here 130 degrees, which would make this 260, which again, all makes sense because 360 has to be the circle, 180 has to be those two angles. So that's pretty good there. All right. Secondly, we had if we have two chords, right? Basically, what it said is that these angles, we know these angles are congruent, but these angles relate to these arcs, but not directly, not like a central angle would, or like it wouldn't be equal like a central angle, or half as much as the arcs like an inscribed angle, because it's neither of those things. But what it is it's going to be the average of these two arcs. So essentially it's going to be, arc 1, it's going to be arc plus arc over 2 equals the angle, right? That's kind of the equation here, right? It's the average of those angles, all right? All right, the other thing that happened is that if I had, it doesn't matter if it's any amount of secant or tangent, some combination of secants and tangents, right? It's going to be this arc, so big arc minus small arc over 2 gives you the angle. So again, it's literally big arc minus small arc over 2 gives you the angle, and that works for any sort of other angle, any series of secants or tangents, right? That's basically what it is. And yeah, it's memorizing these formulas, right? How many people are going to ask me to not take the test tomorrow? How many people are going to ask me that? It's like, just take it. Just take it and get it over with. I'm sick of grading 20 makeup papers the day after. Okay? I'm just sick of it. Like, it doesn't do you any good. Makeup tests are rarely, their scores are higher. Okay? The scores are actually never higher on makeup tests. Take it the day of. Just take it. Just make up the work, figure it out, and take it. I'm so sick of it. I'm sick of making 10 makeup tests, changing little things, and then having to come back and grade them weeks later. I just want them to be done. Rant over. All right, and then 11.6, we just learned it, okay? And it basically deals with the lengths of segments. So we know that in this case, when we have two intersecting chords, that the pieces of the products of the pieces of the chords, add up or equal each other. Sorry. So in other words, in this case, A times B equals C times D, right? It's this piece times this piece equals this piece times this piece. That's how it is. That's how it works. Okay. Secondly, if we have an angle on the outside, with two secants, we do know that we have the full secant segment, right, which I'll just call X. I have A and we have B. So we have the external part and the internal part, and then I'll just do C and D, and then I'll just do sort of Y for this whole thing, for the other secant segment. When I have two of those, it's always external times the whole, right, equals the external of the other one times the whole. So in this case, it would be the external, which is A, multiplied by the whole, which I could write as either A plus B, or I already labeled it. I labeled it already as X, so I might as well just do that. And then the other one would be C, which is the external times either C plus D, or simply Y, right? So those equal each other, you can solve. All right. Yeah, good. That was a good rant. Thank you. 10 out of 10. All right, now I have to delete this video so no one knows that I ranted. All right. All right. Okay. No, lacrosse did not quite win. It was like a really close game. It was, the final score was, hold on, let me get it. I believe it was 21-4. Yeah, 21-4 was the final, and they did not win. All right. Okay. So basically, I think that's pretty much it. Except if you have the same situation happens if you have like a tangent in a secant, it's still external times the whole, right? So it's still the external times the whole. The difference is that it's in the tangent, the external is the whole, so it's like the tangent segment. We just always square it. Yeah. Okay, so I mean that's the rundown of it. It's a few formulas. I mean it's memorizing some formulas, it's memorizing some stuff that happens, and it's using those things to figure stuff out. I mean there isn't sort of a whole lot of like piecing things together. It's kind of a lot of knowing that these are the formulas that you have to do. So you have to, again, you do have to recognize that that's a secant, that there's two secants, or that there's two chords, or that there's no difference except all of it. All right. So the difference between having two chords in 11.5 and two chords in 11.6, this is a question Jesse asked. I mean, one's dealing with the angles, right? It's like these two angles are the average of these arcs. The other one's dealing with the actual lengths of the segments. So you could almost have the exact same setup. It's just depends on what you want. Yeah. Yeah, it's sort of like, again, it sort of depends on what you are looking for and what they give you. I mean, if they give you angles and arcs, obviously that's what the equation you're looking at. If they give you segments, then that's the equation you're going to be looking at. Okay. Good question, though. I mean, so in other words, I said that there's not a lot difference, and that's true. Like the pictures can look identical. It's just, again, what you want. And that goes for two secants and and an angle and stuff too. Right? They look very similar, but yeah, sort of depends. I mean, so I did the rundown. Any other questions that you have from the review packet or from something else? And the review packet does a good job of at least getting you to sort of see the difference between using all varieties of the formulas, essentially. I mean, honestly, I can't make you memorize the formulas, right? I mean, I can't do that part for you. So it's like it comes down to knowing them, having them memorize them, and honestly, if you've done your work at this point, right, then there's no reason why you shouldn't have them at least mostly memorized, considering you've done, 10, 15, 10, 20 problems on the same thing over and over again. So like, that's why I give you the work. It'll help you remember it. So if you've done it all, then I assume that we're good. Okay, so 19 is easy if we remember the one rule, right? So first of all, it's sort of like, oh, what do I have here? Well, it looks like I have a quadrilateral. I'm like really far away from the mic. Hopefully you guys can hear me. I'm just leaning back. We have a quadrilateral that's inscribed in a circle. So we know that the one thing we know about a quadrilateral when we're inscribed in a circle is that the opposite angles have to be supplementary. So in this case, we could just be like, oh, well, this angle P and this angle R are supplementary. So 63 plus 3x equals 180. They add to 180, right? They're supplementary. Also, the other diagonal angles, or opposite angles, would be 65 plus 4y minus 1 equals 180. And of course, you can just solve at that point to get your x and then to get your y. So if you can find two angles opposite of each other in a quadrilateral, that's a good sign. I don't know about the extra credit yet. I'm still finishing it up. If there's room, maybe. Uh, 15 is pretty not so bad too. If you take a look at what we got here. I mean, basically what you have is, and we're trying to find KLM, right? So KLM, well, that's that arc, from there to there. And there's really a couple ways to do it. One of which is that this angle right here is inscribed. Again, I can't ever draw sideways. That this arc is inscribed to this particular angle. So if that angle is 90, we double it to get 180. Or we also know that if this is 38 and this is 142, together those are 180, which means what's left over also has to be 180 from 360. Right, so it's kind of not so bad, if that makes sense. So there's a couple ways to do it there. So sort of take your pick. Either of the ways that I said would be great. 14. Oh. Okay, 14. So basically in 14, I mean the main thing to remember, or a main thing to remember, is that congruent chords cut congruent arcs. So this chord right here, JK, makes that arc JK the same as all the other chords that are the same, right? So this chord, and this chord are all the same, which means that JK, arc JK, arc KL, arc LM, and arc JM have to be congruent as well. So I mean, you can mark them all the same if you want, if this helps. And then you can be like, oh, well, all four of those have to add up. So x plus x plus x plus x, 4x have to add up to 360, which means each one has to be 90. I mean, or you can just go a couple, that's how I would probably do that one. Just think, oh, like there's the four arcs, and they're added to 360, and they're even. Okay, well, divide by 4 essentially. Yeah, let's take a look at number, what was it? 26, it looks like. mean, this is probably the, I mean, all nothing. Like, if you looked at the packets at all, like, these are super, like, the most straightforward you can possibly get. I mean, I mean, it's like, okay, well, we have two chords intersecting, and two chords intersecting mean that these segments, right, so x and 6x, right, the products of those x and 6, the products of those segments and these segments are equal to each other. So the equation that we're going to write is just 6 times x equals 3 times 4. 6x equals 12, x equals 2. Right? I mean, so the idea is basically, I mean, you know the formula for chord segments, and you're good here. Right? It's not even, there's nothing even anything else sort of obfuscating it. It's just sort of, bam, there it is, straightforward, right at you, two chords. I like that there were enough questions we could sort of go a little rapid fire. 28. All right, let's do it. All right, well, 28 is sort of a pretty good representation of one of these rules as well. And the rule is, right, that if I'm dealing with segments, I do know that we have a tangent and we have a secant, so we should sort of be able to identify that, right, with, like, we have a tangent here and we have a secant here and they're intersecting. Right, so we could identify a couple things. One, which isn't part of this problem, but we should know that, like, basically this arc, right, this big arc minus this small arc over 2 would give me that angle if I cared about that, which I don't. But not in this case anyway. There definitely are problems like that, but just not in this particular case. But if we're trying to solve x, that's that internal sort of segment. So I sort of set it up the same way. I go external 5 times the entire thing, which is x plus 5. Right, and that's going to be equal to the tangent segment squared. So the tangent segment always ends up being squared. And you can, you can think about it kind of like the same thing. The external part of it is 10, and the entire thing is 10, so it's going to be 10 times 10. Yeah, I pretty much went through all the sections just relatively rapid fire and like what they were. Again, those, you know, they're in their packets as well, right? So I mean, you can definitely check them out there, and hopefully highlighted and stuff. But they're I mean, you know, when we go over them, you hopefully take notes on them and stuff. But basically, they're all there, yeah. So in this case, if you want to finish it out, though, is that 15? I think that's 15. You can just double check. You're like, well, if that's 15, then that would be 5 times 20 equals 100, and that's true. So we're good. So doing the review packet is going to make you aware of the rules. It's not going to make you aware of when multiple rules are, like, you know, in the problem at the same time or anything. But they you know, so the review packet is a good step in the right direction, but it's certainly not everything. Tristan, yes, correct. What you said is accurate. Like, you can think about them as, you know, it's always external times the whole, or the tangent is always squared. The sometimes it's some combination of these. Sometimes it's external equals times whole equals external times whole. Sometimes it's external times whole equals tangent squared. And of course, if you just have two tangent segments, we know that they're just congruent. So there's nothing to it. Just we know that they're the same. Yeah, the review packet is definitely a good start to make sure you know the formulas. All right, guys. Well, if that is it, then that is all right. I am going to go to bed. So, I will of course leave this up for people to do my rant and make sure you read that. No, but for real, you can go back and you can look. I did go over sort of the individual chapters, not the older ones, not 1 through 3. But 4, 5, and 6. So they're there. They're there. It's a little shorter, but again, I think we went through the review packet. And again, it's if you know the formulas, again, it's a very good start. Like much of the test, of course, is just knowing stuff. But of course, applying it is going to be the other part. The other separates sort of the A's from the B's there. So anyway, that's that. I will talk to you guys tomorrow. If you have any questions, let me know. I'll be available during first or right before school. I might be making copies sometimes during first, but I should be all right. At least there for the most part. I will see you guys later. Catch you on the flippity flap. People say that, right? Yeah, I'm fairly certain. Oops. See you guys.